Okay, so I had asked you to fill in 10 need to know facts on this chapter 1 review sheet. And I gave you the hint that yesterday we went through the homework, the 5 pages of homework, and wrote in some really important facts right in the margins of the notes. So your notes would have looked, or your homework should have looked something like this, where we wrote a bunch of really important facts from this chapter. Can anybody tell me one of the really important facts that they wrote in? I'll go around the room if I don't have volunteers. Connor, what'd you get?
Density scale the dot
When it gets what?
colder.
Yep, that is one really important fact. I'm going to rewrite it a different way, just so you have it. And I'm actually going to write it both ways. So the first, what we wrote in our notes was as temperature goes up. What happens as temperature goes up? What happens to density? As temperature goes up, density decreases. Yep, so then what Connor said, which was also true, is when temp goes down, density goes up. The way to clear this up in your head is when things are cold, they huddle together. So they're more tightly packed. When you're hot and sweaty, you spread out. So you're not tightly packed, you're less dense when you spread out. That is one really important fact. Technically 2, but it's one concept. What's another important fact that what you could get right out of your notes that we did yesterday or somewhere else? Yeah. Okay, so the key there is most substances are most dense as solids. If you don't have this important fact, even if you already have 10 and you don't have this important fact, notice there's another space for 10 more on the back. So if you haven't had the same facts that I'm writing down, I need you to write them in because this is what you need to know for the test on Monday. Yeah.
I did the pyramid.
You did the what?
The triangle.
Triangle is another important fact. Abso-freaking-lutely. And what is on the top? M has to go on top. D and V can go off to the side. So again, remember, you cover up the one you're looking for. So I'm just going to write this. So if I'm looking for M, no, the D and the V can swap places as long as the M's on top. So M equals D next to V. So multiplying. D equals M over V, and V equals M over D. So you don't have to memorize the equations as long as you know that the M is on top and how to use the magic triangle. What else should we include in here? Same material will always have the same. This has 2 meanings. So one thing is you can pick up a piece of gold from anywhere. even if you weren't sure if it was gold, you could determine its density, divide mass divided by volume of that piece of gold. And this is what the people who went gold mining would do, is they weren't sure if it was gold, they would figure out the mass of the piece of gold, figure out the volume of the piece of the gold, and divide mass divided by volume. And if it had the same density as what they knew was gold, so if you had a gold block and you knew that was gold, if they have the same densities, then your piece must be gold too. Yeah. Okay, 1 second. Along the same lines here, this is where size does not matter. So when you're talking about density, size does not matter. Connor, was your other one different?
Yeah.
What's your next one?
I thought when pressure increases, density increases.
Yes. So as pressure increases, density also increases. Somebody else got one? I couldn't hear you. Nope, volume's gonna decrease. Volume's how much space it takes up. So let's add those two about volume. Let's do temperature first. As temperature, I'm gonna shorten it up with an arrow. So as temperature goes up, what happens to the volume? Volume also increases. And then same with, or opposite, I guess, as pressure goes up, what happens to volume? Then it goes down. And that's part of it. If the size gets smaller, but you have the same amount of stuff, they're packed in tighter. All right, what do you got, Jake? Scientific notation. So you can just maybe maybe just an example. Let's do that. 65 million, which is 65 with 6 zeros, is 1, 2, 3, 4, 5, 6, 7. 6.5 times 10 to the 7th. What else from this chapter should we include in this cheat sheet? Rate of change. What is rate of change? Yep. Change in value. Oops, I'm writing too big. Divided by the time it takes. Change in value divided by the time it takes. Got another one, Jake?
I said, like, understand the data,
Okay, so how do you read a graph? So we always started off with as, and I filled in the blank, which was x-axis. What does the x-axis always do? As x-axis increases, then what do? You read the y-axis, you say the name, and then you read the line. So as x-axis increases, then you just read the y. So then you say whatever the y-axis, and then you tell me what the line is doing. If it's increasing, decreasing, or staying the same. What are some more? There's a few more that we should definitely include in here. What about water? What do you got? I didn't write anything about water yet. Okay. Unlike other substances, water is most dense. I'm going to include the temperature. Who remembers the temperature? Yep. So this should be water is most dense as a liquid at 3.98 degrees Celsius, which by the way, you can call 4 degrees Celsius. So on the same note, ice is less dense than water.
So if I froze.
Yeah, so apple juice is still mostly water. So like if you,
If you froze another liquid, would it float like ice does in water?
so it depends on the density of that liquid. So how about if I go this way? If you put ice in pure vodka or pure whiskey, well, it does eventually melt, yes, but it actually sinks to the bottom of the cup. But ice in pure water, the ice will float. It's along the same lines of what you were saying. Start again. So yeah, so the density of alcohol is less than the density of water. And somebody asked me in a different class, like, when are we ever going to use density? And I'll tell you, in most of my daily life, I never use density, but there are a few things that I do use it for. And my brother, so weird enough, my brother was a giant delinquent in school, got in trouble every single day, was constantly getting kicked out, things like that. Well, now he is a professional brewer. He brews beer for a living. He works for a company, they are owned by Anheuser-Busch. So he is a master brewer. So this idiot in high school is now a master brewer. He makes his own beer and then they sell it at this brewery. Uses density. Density is a huge part of brewing beer. Like you have to have the right density of the beer to like, that's part of how they know it's ready. In my daily life, I don't use it, but I also make maple syrup. And those of you who make maple syrup know you have to drop in I don't know if it's called a hydrometer, I can't remember, but that's density, whether it floats or sinks is density. And so density does pop up. You need to know densities of fluids that you're putting in the cars sometimes. So density does pop up in real life. Do I use it daily? No, but it is important to understand the basics if you're going to be doing certain things. So who would have thought my brother would have been using something he was supposed to learn in high school? Guarantee you he didn't learn it in high school.
Does salt add a lot to the because I see in this one, the river for the sea, the Black Sea, people can just float.
Yes.
Because it's so salt.
Perfect. That's a perfect example. So salt water makes the water more dense. Because think about it, if you're going to the equation of density, you work through it, okay, let's do it this way. Density equals mass over volume. So you still have the same volume of water. So let's say the pool can hold 100 gallons. That's your volume. Let's go here. That's your volume. Yeah, I'm just making numbers up. So you have 100 gallons. And let's say your regular water, and this is true, regular water will weigh, and this can't be gallons, this has to be, let's go to milliliters, and if this was grams. Regular water, because water has a density of 1, will have a mass of 100 grams and its water will be 100 milliliters. But if you add salt to this, what's going to change in this equation? You're adding salt to the water. The mass of the water. The mass is gonna weigh more because I'm adding stuff that's just gonna dissolve to the water. But the volume doesn't change because it just dissolves in there. Doesn't, so what? Water dissolves the salt. So I think it's the same as what you're saying, but not really the science that happens.
I thought like salt was in the water.
No, water dissolves salt. So then if the water now weighs a little more, it's still gonna have the same volume. So when you do the math here, this equals 1, this equals 1.1. So the density of salt water is a little higher, which then means people will float a little easier. Okay, so wait, one question at a time. What was yours? So not all people have the same density, which goes along with this question. How dense are people? Why do you have to drink water all the time? Why do they tell you? To hydrate so you don't die. But one thing is the human body is made mostly of water. Our density is very close to water. Do we sink in a pool? Like sink to the bottom? No, no matter what, you don't sink right to the bottom usually. The only way to sink right to the bottom is to try. So if you just go in the water and you don't try to sink and you don't try to float, you know how to make yourself sink, yes. And you know how to make yourself float. But if you don't try, if you're just a wet noodle, like a dead body perhaps, what does the body do? Does it float at the top like an empty water bottle though?
No.
No. In fact, that's why people drowned, is that we don't float all the way at the top. We float in the water. That's because our mass is, try it again, our density is just about 1. We're slightly more dense than 1 because we also have bones and muscles, so that we do sink a little bit. Do all people have the same density? No. In general, men are more dense than women because they have different body parts, and there are body parts on women that are more fatty than the body parts on men. More muscular people are more dense than fatty people because the density of muscle is much more dense than the density of fat. So similar, but slightly different. What?
So you're saying, how are you on a pool? Like, how do you want to pool get? I'll be going at a different level against our trust.
Yes.
Yeah.
Yes. Because, and even if you don't poop versus if you do poop, your size of your body is still the same. So your volume of your body is still the same, but your mass changes. So if you add in a lot of liquids without peeing, you're going to be a little, and you guys who wrestle know this, you're going to be a little bit heavier when you're hydrated than when you're not hydrated, and when your bowels are emptier than when they are full, and your bladder the same thing. So if you weigh a little bit more, do the math, your density is going to change slightly. Not much, but slightly. You don't believe me? You do. Anyway, let's keep going. There's still a few more here that we don't have that I want to make sure you know for the test. Anybody else have one that we haven't covered yet? Yes. Make sure you know observations. Observation, what is it? Yep, uses 5 senses. So it's just something you flat out see, hear, taste, or touch. The water is cold. The room smells bad. The wall is white. That's simple. Okay, I didn't necessarily mean mine. It is. Why am I having a brain block here? I don't want to infer. Yeah, okay, I was doing it right. Inference. What's an inference? A guess. Something you assume. So the room smells bad was your observation. You could guess someone farted. You could also guess someone pooped in the corner. You could guess that Mrs. Ritz ate salmon for lunch. Okay, there's a whole bunch of reasons the room would smell bad. It's filled with teenagers. Just saying. Connor, what's a prediction? Yep. So I could guess Mrs. Ritz's room is still gonna smell bad tomorrow. Mrs. Ritz will clean up the pile of poop in the corner. Anything that has the will or will be or is gonna, that is a future question. Anybody have anything else we did not include? You good? I'm satisfied with this review sheet. So what are you gonna do with this review sheet, or what do I hope you do with this review sheet?
Review it.
Review it. These facts are facts that you just have to know. You must know all of these things for the test on Monday. Yes, of course, there are a few more things you should know, and you should make sure you know how to use these. But bare minimum, you need to know these. So one thing you could do to study, since you have these nice, neat and organized, ask someone else, hey, could you just like quiz me on these and make sure I know what they are? So like for this one, they could say as temperature goes up, density does what? You would fill in the blank. You can do that for yourself. Cover them up, see if you can repeat what they are. I know you don't usually study, and I know some of you aren't going to study, but I will remind you to make sure you know these 13 things. Oh, we still gotta go over your homework, guys. So take out your homework, it was page 21. So take it out and go over it while we're going over it. Fill in the answers so that when you are checking your work, no, you don't get credit. It's that ship has sailed. So again, I do apologize. You didn't have to do the ones that said percent error. So there was one there. And here's percent deviation. You did not have to do those. So a student measures the volume of the rock to be. So we have V equals 48.6. And they calculated the D equals 5.3. So we need to calculate the mass. Using the magic triangle that we still have right here, mass equals D times V.
257.58.
Yeah, so when you plug this in, so 48.6 times 5.3, you get 257.6. In science, we always round to the nearest tenth unless they tell you otherwise. All right, this question actually is very similar to what we've been talking about, floating and sinking in a pool. So it says, base your knowledge to questions 2 through 4 on the diagram below. The diagram shows the location of 4 objects, A, B, and C, and D, after they were placed in a container of water. So which one of these is most likely an ice cube? Is it going to be A or B? I heard 2 different answers. Picture an ice cube floating in water. Ice cube in water. I just want to see this freaking picture.
How would the icebergs?
Icebergs is another example. Let's do that. Ice in water. You've seen these motivational pictures, I'm sure. That's a perfect picture. What do you notice about the iceberg in the water? Half floating? Do you not know your fractions?
No, yeah, well, that is Less than a bit.
Yeah, 3/4 of it or even more of it is underwater.
I'd say 4/5.
Not important. Which one of these is ice floating in water? B. Ice does not float like a beach ball in water. Ice floats mostly underwater. Which one most likely has the density the same as the liquid? C. Why is it not A? A is clearly floating, so A is less. So list the objects in order from highest to lowest. What's the most dense? D. Then C. There you go. What is the density of an irregular shaped object that has a volume of 3 and a mass of 12? So D equals M over V. So we have a mass of 12, a volume of 3. That gives us 4 grams per milliliters per milliliter. If we cut that object in half, what will the density be? 4, or if you wrote the same, that's fine. As the volume of air expands due to heating, describe the change that will occur in the density. Yep, density will decrease or get lower or arrow down. Base your answers to 8 through 10 on the data table. The table shows the mass and volumes of 3 liquids, A, B, and C. Be careful because they're messing with you. Here's the mass. Here's the volume. So you have to do mass 400 divided by 500, 0.8. 500 divided by 500 is 1, and 600 divided by 500 is 1.2. So list the liquids in order of decreasing. What is decreasing density? Going down. Do not write 1.2, 1, and 0.8. C, B, A. When they say list them or name the letters, don't write the actual density. If half of liquid A is removed from its container, how will the density of the remaining liquid compare to the original? Stays the same. You have no actual homework today. You just have a test on Monday. Make sure you're ready. Anybody have any questions? Okay.